Welcome back, guys. I'd like to go over one more time this problem because it is a fairly tricky problem. If you notice here, NaCl, let me get back to my pen, NaCl and Cl2 were the two chemicals involved in the problem. So I wrote the molar mass of NaCl, I wrote the mole ratio between NaCl and Cl2, and that came from the balanced equation. And I wrote the molar mass of Cl2. In this problem, I'm starting with 2.3 moles of Cl2, and I'm ending with grams of NaCl. Because I need to involve grams of NaCl, I'm going to have to loop in the molar mass value for NaCl, which is that. I always need to use the mole ratio value, and from there I'm good to go. This last problem is a great problem, great review for the final. It says the combustion of methane. Well, remember, combustion is something plus O2 produces CO2 and H2O. That something is methane. Methane equals C1H4. 1 times 2 equals 2 plus 2 equals 4. C1H4. Is it easy? Ciao. 1 carbon, 4 hydrogens, 2 hydrogens, 2 O's here, 2 O's here, it's 4 total O's. I'm going to have to put a 2 there to balance it. Put a 1 in the front. For the first problem, according to the above reaction, that should say how many? Silly Mr. M. How many grams of carbon dioxide, there's carbon dioxide, are produced if 10 grams of methane, there's methane, fully combust? So the chemicals in the recipe are carbon dioxide. Not tricky because I gave you the word, but I'm sure we all remember the carbon dioxide as CO2. In this case, methane is CH4. By deductive reasoning, we know it's not water, we know it's not carbon dioxide, and we know it's not oxygen. The molar mass of carbon dioxide would be 12 times 1 plus 16 times 2. That's going to be 44. Oh, what happened? Crazy. 44 grams per every mole of CO2. The mole ratio, in this case, is a cool one. It's 1 to 1. 1 mole of Cl2 for every 1 mole of CH4. 16 grams per every 1 mole of CH4. We're good to go. Let's set up the problem. Our crisscross. You have 10 grams of methane. And you want grams of CO2. Start from left to right. Grams CH4, so we're going to have to use the molar mass of CH4. Grams CO2, so we're going to have to use the molar mass of CO2. And we always have to use the mole ratio bubble. Here we go. Grams CH4 in the bottom, because that's what you got. There it is, right there. 16 grams of CH4 per every 1 mole of CH4. Done with this one. Mole CH4 on the bottom, because that's what you got. There's the ratio that has mole CH4. For every 1 mole of CH4, there's 1 mole CO2. Boom. Mole CO2 on the bottom, so what you got. There it is. 1 mole of CO2, 44 grams CO2. Done. So 10 divided by 16 times 44, I skipped the ones, equals grams CO2. Okay, so it's going to be some number a little bit less than 44. Have a great day, guys. See you tomorrow in class.